Assalamualaikum. My name is Muhammad HAFIZUL bin ROBI. Number metric DE180129. Okay, today our group will present about our project. First of all, introduction of our project is this project is required us to derive and solve the two tasks given. For the first task, we need to fit all the three pictures of the model and analyze its outcome. And for the second task, we need to use two pre-trained models and compare its outcome from the result obtained in task 1. Okay, for the second point is we need to use a Google Collects in order to improve the training session, make it much more faster. For this, for this project, we show standard Python programming based on the Spider platform. Okay, for our last part is this project we must know to write the detail about the model, and we can explain what the content or what the input what we get from our graph. Okay, that's all. You.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haniff Amdan. Now I would like to present about methodology. For the first task is we have 5 methods that we use. The first is activity regulation, that is penalize the model during training based on the magnitude of the activation. Second, weight constraint. Constrain the magnitude of weight to be within a range or below a limit. Number 3 is dropout. Possibilistically remove input during the training. For the number 4 is noise. Add statistical noise to input during training. And the last one is early stopping. That is monitor model performance on a validation set and stop training when performance degrades. Most of these methods have been demonstrated or proved to approximate the effect of adding a penalty to the loss function. Each method approaches the problem differently, offering benefit in terms of a mix of generalization, performance, configurability, and computational complexity. For the task 2, that we have four methods that we use. The first is using pre-trained CNN features. Second is learning domain invariant representation. Third is making representation more similarly. And the last is confusing domain. For the classifier, the pre-trainer model is used directly to classify new image. Second is stand-alone feature extractor. The pre-trained model or some portion of the model is used to pre-process image and the extract relevant feature. Third is integrate feature extractor. That is the pre-trained model or some portion of a model is integrated into a new model, but layer of pre-trained model are frozen during training. The last one is weight initialization. The pre-trained model or some portion of the model is integrated into a new model, and the layer of pre-trained model are trained in concert with the new model. Each approach can be effective and save significant time and develop and the training a deep convolution neural network model. For this task it may not be clear as to which usage of the pre-trained model may yield the best result on the computer vision test. Therefore, some experiment may be required. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD AMANI bin SUBERY. Now I will want to present our simulation about assignment 2. Okay, now I want to, the first thing we must upload from Google Drive. The first one is content. After that, we go to Drive and my Drive and to my version and see all the thing in there. Okay, after that we have a training and have campaign and validation campaign and the 3 photo that I capture from bottle and can. Okay, for that we run that, okay, and see the result and have a can trim, pack trim, can valve, pack valve. Okay, now we run our simulation. Okay, now we use VGG for the model, pre-model, and we run that. Okay, this is our VGG, model VGG, and this is input block and others. We run the next coding, and this, okay, sequential. We run that. Also for this coding to get a graph. Okay, now we want to explain this. We can see that is we use step for push is 10, is push 15, and the last one validation step 10. Okay, this is our e-push starting from 1 to 8 until 15 that I have set e-push 15. Okay, we wait for a few seconds to see our simulation. Okay, we can see that it push 15 over 15, and now we want to see our graph. This is coding to plot a graph. Okay, now we can see that this is our training and validation accuracy for this simulation, and the graph, second graph is training and validation loss for simulation. Now we want to continue with another pre-model is the snake and inception. Okay, now we continue with our next pre-model. This is about inception pre-model that I have choose. The first one is same, and we run. Also same, and okay, this is same, and we know that have a can train length, pack train length, can validation length, pack validation length, and my portal length. Okay, now for inception, we before that we choose VGG at this import, and now we change with inception version 3. Okay, we run that. Also we run. Okay, for sequential have this detail. Okay, this also can see that, and we run that. Okay, now this also we run for all image be the scale. Okay, now we found image 460 image into classes and 210 image to classes and database label of base shape 20. Okay, that is now the last thing we have to run this model for epush. For step per epush same. Before that 10, epush 15, and validator step is 10. Okay, now we wait for a few seconds for epush calculating until 15 over 15. Okay, we wait a few seconds. Okay, this is 10 for 15. And can see that this is our loss, accuracy, validation loss, and validation accuracy at the side of the push. Okay, now we arrive 15 over 15, and now we can simulate our graph from this coding. Okay, for this coding, we can see that it's different with a VGG. Okay, this is a training and validation accuracy graph, and the second is a training and validation loss for the graphs. We can see that our graph like that and this graph like that. Okay, now we continue with our next pre-model that I have to is the last one of the pre-model is about our the snack. They also same but we change to our application import the snack that I have used the snack 1 to 1, and all the things are same, also same, and the next one. Okay, now this simulation I have run before that. Okay, we can see that this coding image will scale. Okay, and now I found database label base shape. Okay, now this for step for epush same before 10, 15, and validation step 10, and we calculate until 15 over 15, and this is coding to plot the graph, and we can see that our graph is different with to our VGG and our exception that I have shown before that. Okay, this graph and the snare also VGG, when we run, this is different because of the sequence is different. Okay, we can see that this is the first graph, training and validation accuracy, and like that, and the second graph is training and validation loss. We can see that for the snare, this is like that for the graph. Okay, that's all for me for our presentation of simulation. Thank you.
Okay, Assalamualaikum. For the conclusion of our project, first, we gain the information about how to use a Google Colab by using a standard Python programming platform. Furthermore, for the last result of our project, we able to complete all the tasks given. Okay, for the second point is the major point of the project is the last of our project. All the group members have been able to use a Google Colab and understand what we get from this project and achieve the objective to improve the training session and make it much more faster. Okay, for the last point in a conclusion, all the objective we have been achieved and all the results have been attached in our report. Okay, that's all from our group. Thank you.